Welcome to the next topic, laser. Laser is nothing but the abbreviation is light amplification by stimulated emission of radiation. The characteristics of laser are it is highly directional, highly coherent, monochromatic. Monochromatic means only one color, that is single wavelength. Angular spread is less. When you compare to the ordinary light have angular spread is more. But in laser, you can point the light on the particular direction, so it will have high directionality, and coherently in the same phase you can point the particular position. So that's what it is called as highly coherent, monochromatic, highly directional, and the angular spread also is very less. Next, we'll deal about the absorption, spontaneous process and stimulated process carried out in the laser. So that process, it is derived in the form of Einstein derivation. So this Einstein derivation is nothing but it is used to find out the ratio between the absorption process, spontaneous process and stimulated emission process which is carried out in the laser action. Now let us see the absorption process first. Absorption. So absorption is nothing but, let us consider two energy level, E1, this is E2. Let us consider the atom present in the ground state energy level. When a light which consists of photon, we call it as a h nu, which is made to incident on the atom, it absorbs the energy and it will move towards the excited state. So this is called as absorption. So rate of absorption is given by R12, that is directly proportional to N1 rho nu. R12 is nothing but rate of absorption takes place from the ground state energy level to the excited state energy level, and N1 is nothing but number of atoms in the ground state energy level, and rho nu is nothing but the density of the incident radiation, this one. Or else this equation can be rewritten as R12 is equal to N12 B12 rho nu. So B12 is nothing but a constant term. So we write as equation number 1. Next one, spontaneous emission process. Spontaneous emission. Again we will consider the two energy level E1, E2. Now the atoms after absorption, it is present in the excited state. Spontaneous emission is nothing but the atom present in the excited state will come back to the ground state without any external source. Automatically, spontaneously it will come back to the ground state. So that is called as spontaneous emission. So here rate of spontaneous emission is given by R21 spontaneous, it is directly proportional to N2. R21 is nothing but the process takes place from the excited state to the ground state. SP represents the spontaneous emission and depends upon the number of atoms in the excited state. Or this can be written as R21 spontaneous equal to N2 A 2 1. We write as a equation number 2. Again A21 is a constant. Next we'll move to stimulated emission. Again we'll consider the two energy level E2, E1. The atom is present in the excited state. So here with an external source, it can be a light, it can be electron, it can be electric energy, anything. With the external source, the atom will come back to the ground state by emitting 2 photons. Okay. Again these 2 photons will get moved toward the excited state. Again with the external source, it again come to the ground state by emitting 4 photons. So it get doubled. So that is called as stimulated emission process. So that is given by R21 stimulated is directly proportional to N2 rho nu. Why rho nu? Because it depends upon the incident radiation. Or R21 equal to N2 rho nu B21. Again B21 is constant. So you will get the intense beam here. So out of these three, where you will get the most intense beam? Stimulated emission. So stimulated emission is a process used for the laser action. Okay. Next. Under equilibrium condition, rate of absorption equal to rate of emission. So equation 1 equal to equation 2 and 3. So we will write like this. Now bring this term to the left hand side, take the common term outside. So N1 B12 minus N2 B21 equal to N2 A2. Or rho nu equal to N2 A21 divided by N1 B12 minus N2 B2. Now, divide the numerator and the denominator by N2 B21. So, what will happen? Rho nu is equal to N2 A21 divided by N2 B21. Afterwards, we cancel. N1 B12 divided by N2 B21 minus N2 B21, it will get cancelled. So, this also will get cancelled. So, rho nu is equal to A21 by B21 into 1 divided by N1 by N2 B12 by B21 minus 1. Let us write this as an equation number 4. Already we know the Maxwell-Boltzmann distribution law. Nn is equal to N0 e power minus En divided by kBt, where n is equal to 1, 2, 3, etc. If you take as a 1, N1 is equal to N0 e power minus E1 divided by kBt. Similarly, if you take n is equal to 2, so N2 is equal to N0 e power minus E2 by kBt. So N1 by N2 is nothing but what you will get, this one will get cancelled, e power E2 minus E1 divided by kBt. This E2 minus E1 is nothing but h nu. So e power h nu by kT. Now substitute this N1 by N2 in equation number 4. So we get rho nu equal to A21 by B21 1 divided by e power h nu by kBt into B12 by B21 minus, okay, this equation 5. And this equation 5 have a good relationship with the Planck's radiation. 8 pi by C. Now into 1 divided by e power h nu by kBt minus 1. You take it as 6. Now equate 5 and 6 with the condition where and all you are having A21 or A12, you take it as a A. Where and all you are having B21 equal to B12, you take it as a B. So what you will have if you compare this one? A by B is equal to 8 by h nu by C. So this shows that rate of absorption equal to rate of emission. So where A and B is called as Einstein coefficient. Okay. Now, what are the components which are responsible for the laser action? First one is active medium. So each and every laser you will have the active medium. From the active medium only the laser action takes place. If you take helium neon, helium will be taken as an active medium. NdAr laser, neodymium will be taken as an active medium. That is the whole responsible to produce the laser action. Next, pumping source. Pumping source is nothing but this pumping source is used to produce population inversion. Population inversion is nothing but number of atoms should be more in the excited state when compared to the ground state. Then only the emission process will take place as an intensely or coherently. So that is called pumping source. So pumping source already we told that can be a light, that can be an electric field, electrons, direct convection, it can be anything. Okay. Next one is optical resonator. Optical resonator is nothing but it consists of fully reflected and partially reflected mirror in a laser beam, laser apparatus. If intense beam comes out, it will be moves to and fro between the reflecting and the partially reflecting mirror, and the output you will be getting from the partially reflecting mirror, because fully reflecting mirror it get reflected, it won't comes out. So from the partially reflecting mirror the laser beam will exit. I already told the pumping source is nothing but is responsible for the population inversion. First one is optical pumping. So optical pumping is nothing but here light will be used, photon will be used to trigger the atoms present in the excited state to move towards the ground state. Second one, direct electron excitation. This is nothing but by using electric discharge, electrons will make the atoms in the excited state to get stimulated, comes to the ground state. Next one, direct conversion. Here directly electrical energy will be converted into a light energy, that is laser. Next, inelastic atom collision. Inelastic atom collision. Here, if two atoms are made to produce the laser beam, for example, helium, neon, first the electron will combine with the helium and makes the helium to move towards the excited state. Now, after hitting the metastable state, the helium will comes down and reacts with the neon and makes the neon to move towards the excited state. So that is called inelastic atom collision. Next, chemical reaction. So due to chemical reaction also, you can obtain the laser beam. So that's all about the population inversion process and introduction and the components required for the laser beam. Thank you.